And this is a presentation for core 3. Take puppy out for a walk with 于超章、殷英东、郝月曾、浩高 and me, 司玉和. There, I will show all our work in this presentation. So first, we should know what the puppy is. So the puppy is a running robot which has more degrees of freedom compared with wheeled robots. It has a very simple design where its behavior is stable. So let's see how puppy run in the real world. So this middle dog can run on an even floor. And in this time, our task is make puppy walk outdoor. We will not let see the structure and the controller of the puppy. So this the structure of puppy in V-box. There are 4 motors on the body. The puppy is powered by those motors. Between femur and tibia, there is a spring to absorb the shock. And all the motors have a very simple control. So this is the controller of puppy. The target angle of each motor for the forelegs and hand leg respective was determined as the equation on the left side. So it just move the legs back and forth. The right side are the controller parameter. So we just use those to change the gain of puppy. So let's see the puppy run in the V-box. So it can run. We can see the puppy in the V-box can run on the even floor. So what this puppy will happen when running outdoor. So we can see this video. So it can run on the floor, flat floor, steady, but when puppy arrive on downhill, it will fall down immediately. So how can puppy run steady on an even terrain? So first, we thought that if puppy easy forward, we may change the path of each leg. Like left side equation showed, the left foreleg and the right hand leg move together. It is the same for another 2 legs. So let's see this video. But it is not steady, and it is too easy to right side. So what is important for puppy to not fall down? When puppy walk on downhill in vertical direction, projection of the center of mass will too close to the fulcrum. Since Pabi ran forward, it was very easy to fall down. So we thought two ways to let Pabi not room so easy to fall down. First is keep a center distance between the fulcrum and the center of mass. The other is to reduce the height of the center of the mass. The center to reduce the height of the center of mass, you also have two functions. First is to change the spring constant, and the other is to increase amplitude of the motor. So since change the springs seems impractical in the real world, so we choose another way to change the amplitude. To change amplitude, we should add torch sensor on each tibia. The torch sensor on the bottom of the feet that indicated when a foot is touching the ground and return a pressure value. The pressure value can be used for change the amplitude. And then we reduce the amplitude of the product, so it is not too easy to fall down. The red is on the right side is a portion of our hobby. So it can run steady on the uneven floor. So because we reduce the amplitude of the products, so in no feedback of the touch sensor, it also can run with small scope, but with no feedback, it's easy to change the direction. So we can see the video on the right side. It is not so easy to change Pabi's direction. So that's all. Okay. Thank you very much. Thank you very much for attention.
Okay, thank you very much. Let's give a little applause, guys. Okay, so I just need to. I assumed 5A and 5B was coming up, but this was actually group 3B, right?
Yes.
Yes.
Okay.
All right. Thank you very much. Do we have any questions from the panel? Anyone want to start?
Well, we saw a real image of the robot at the beginning of the presentation. So I'm curious if you have been able to test these behaviors with the real robot.
Sorry?
You show... Yeah, I can repeat, no problem. We saw the real robot in a video at the beginning of the presentation.
Yeah.
So I want to ask you if you have tested these algorithms on the real robot also.
So
Slide number 3, yeah, there is the real robot.
Yes.
But have you tried, this is with all of your modifications?
So we try, this is the simulation of the real puppy. Yes.
Yeah.
Okay.
Okay, so probably just implemented in simulation, right?
Mm-hmm.
I thought it was quite a nice simulation you did where you put it in a nice hilly environment. I wanted to ask you. So the puppy right now has some passive compliance just in the kind of I guess it's the knee joint or the ankle joint. Do you think there's any other things that you can make passive on puppy to make it even more interesting? Are there other things you can think about?
So I think puppy can it will change the puppy's spring. The length of the puppy springs will also can change the gain of puppy. I think maybe it will make him steady, but
okay, change the springs to make them different. Okay. Any other questions?
No, just a comment. I think it's a very nice implementation. Of course, you did it so I understand you did it so far in simulation, but I think it's a good implementation. It's good. Thank you.
Thank you very much.
Thank you very much. All right. If there's no further questions. All right, let's thank the presenter again. Thank you very much.